I'm Todd. This is Arun, and we're glad you could join us. Let's talk a little about Firebase Analytics. So I'm guessing many of you are app developers, and you're wondering how Firebase can make your life a little easier. Maybe you are BigQuery aficionados, and you're wondering how you can put your elite BigQuery skills to use in a Firebase world. Or maybe you just wanted somewhere kind of quiet to check your email. And that's fine, too. We won't judge. From up here, it kind of looks like you're taking really good notes. So keep doing it. So I'm going to start by explaining what Firebase is, because I think a lot of people still think of it as just a real-time database. And honestly, Firebase is a whole lot more than that. It's really a whole suite of services available on iOS and Android and the web, designed to make it easier for you to build successful apps. And these include everything from a cross-platform notification service with Firebase Cloud Messaging, to Remote Config, our fun little toolkit that lets you change the look and feel of your app from the cloud. I don't know if you've heard about the cloud, but I think it's going to be big. Mark my words. To, yes, the real-time database. To a whole bunch of other features that I'm not really going to talk about today, because at the heart of all these features is this thing here, Firebase Analytics. That's why we drew it in the center like that. It's like a visual metaphor. So I think anybody who's worked on a successful app knows that analytics are really important to building on that success. It's really the best way to find out what people are actually doing within your app. And by finding out what users are doing within your app, you can make it better, right? Like you can find out places where users are getting stuck, if there are features that they're not using, or if there's parts of your app that are sort of way more interesting or sticky than you anticipated. And then you can adjust your app accordingly, according to what your users are actually doing. So there are a lot of libraries out there designed to help developers measure what's going on within their app. Google Analytics was one of the earliest of these, but it was really targeted more for websites. And you can kind of see that in the way it was designed and the way it's set up. It's got kind of a lot of web pagey terminology in the reports and in the way it processes information. It also limits you to about 10 million hits a month before you need to upgrade to an Analytics 360 subscription, which we know for sort of a lot of small indie developers might be a bit of an issue. Firebase Analytics, on the other hand, was built from the ground up to be mobile-centric. It comes at no cost to you and supports an unlimited volume of hits, no matter how many millions upon millions of users your app might have. So from our perspective, this really is the way that mobile app developers should be measuring what's going on within their app. So let's take a closer look at how Firebase Analytics treats data, because if you are going to be dealing with this data as a BigQuery developer, it kind of helps to know what it looks like underneath the hood. So Firebase Analytics is really all about events. Nearly everything you want to record within your app, whether it's a user opening it for the first time or making an in-app purchase, visiting your store, completing a level, is going to be recorded as an event. Events have names, and then they also have up to 25 key value pairs or parameters that are passed along with them. And these parameters can be used to store any kind of interesting data about the event that you as an app developer might want to know. Some events within Firebase Analytics are recorded and submitted automatically for you by the mobile libraries. These are things like in-app purchases, or the user updating their operating system, or your users opening your app for the first time. The library can sort of automatically detect these events and submit them for you. Then there's a whole bunch of suggested events that are predefined by Firebase Analytics, and these tend to be events that are sort of fairly common to a number of different apps. Things like adding an item to a cart in an e-commerce app, or conducting a search. Now, unlike the automatic events on the previous slide, you'll need to submit these events yourself. And don't worry about the tiny font, those of you taking pictures, hoping your resolution's good enough. We have documentation that lists all of these. But I think the majority of the events that you will be sending within Firebase Analytics are custom events. These are events that you define specifically for your app, and you can define up to 500 different types of custom events. And really, these can be anything that's relevant to your app. Maybe that's like completing a workout in a fitness app, or unlocking an achievement in a game, or viewing a recipe in a cooking app. And that's basically events in a nutshell. The other important type of data I want to cover for Firebase Analytics is user properties. And these are, well, properties associated with a user, hence the name. So the idea behind user properties is that as a user interacts with your app over time, you might learn more about them. Like you might learn what their fitness goal is for those of you with fitness apps, or what their favorite musical genre is for those of you with sort of music apps, or how they pronounce GIF, which as we can see here is the correct way. And so the idea here is that you can use this information to filter your events by these user properties. Like maybe you're curious if your yoga enthusiasts are spending more money within your app than like your weightlifters. And so you can go ahead and filter your in-app purchase event by this fitness goal user property. And you can start to see for yourself who's spending more money in your app, the weightlifters or the yoga people. And then maybe you can adjust sort of your marketing spend accordingly. And that's basically it. Just by using events and user properties, you're able to supply Firebase Analytics with all the information it needs to give you some pretty useful information about your app in the form of some very nice looking graphs. So in fact, let's take a look at some of these right now. So these are some of the basic dashboards you'll get essentially without any other work as soon as you integrate the Firebase SDK. Excuse me. OK, so here we've got active users. These are users who are interacting with your app over a defined time period, in our case, the last 30 days. We have average revenue per user, known as ARPU, and average revenue per paying user, known as ARPPU, which is my favorite acronym ever. We have retention cohorts, which shows you how frequently people come back to your app over time, and this is usually broken up into sort of weekly groups or cohorts. We have user engagement, how much time people spend within their app when they're actually using it. Your top in-app purchases, and if we scroll down a little bit, we can see like who your users are, where they're coming from, and a whole bunch of other useful information. But I actually don't want to spend a lot of time on these initial dashboards because I'd like to spend a little more time talking about events. So any event that your app records, whether it's a Firebase automatic event or a custom event that you're logging, shows up here on our events panel. And if we were to click through on one of these, we could start to see more details about this event as it occurs within our app. So let's take a look at 3 of these examples. This first report here is for the in-app purchase event. And you can see we sort of have, again, sort of through a series of graphs, the number of times this event occurred, again, in the last 30 days. We can see the number of unique users, or I suppose more accurately, app instances that have performed this event. We can see average events per user, and then the total value of purchases during this time period. We also have a few custom reports for net purchases. In this case, we can see what the top products are that our users have purchased, what our average purchase price per item was. And then if we scroll down a bit, you can see, again, we get some nice demographic information about the users who are performing these events, as well as an events per session graph, which sometimes comes in useful. And then you can see we have similar reports for like our level up event. This is one of those suggested events that Firebase Analytics already has predefined for game developers. And also an unlock achievement event. This is a custom event that the developers of our sample game, Bingo Blast, have created on their own. And so we can learn a fair amount just by looking at these stock reports, right? Like my in-app purchase report will let me know sort of what products are most popular. And I can do things like filter this report by some of our user properties. For instance, I can filter our in-app purchase event by operating system version. And that can sort of start to inform some important decisions like, gee, how backwards compatible do we want to be, right? Like if it turns out users who are on OS 8 are still spending money within our game, well, then maybe that makes sense to kind of make sure that we can still support those users. And we're able to give you these kind of reports for no cost, no matter how many millions upon millions of users your app might have. So maybe this sounds too good to be true, and you're thinking what the catch is, and I'm glad you're silently thinking that to yourself, because that's the rest of this presentation. So I want you to take a look at this graph again, or this report. You can see that our in-app purchase event gives you some very nice information about some of the custom event parameters that it gets in, right? In our case, the product that was purchased and how much those items cost. You can also see for a predefined event, like our level up event, we get a nice little bar chart that shows you what new level our users have reached when they reach this event. But then if we go back to our unlock achievement event here, and this is a custom event, we don't see any information about the actual achievement that our user has unlocked. Like right now, if we want to know what achievements are most popular or which ones are sort of harder to unlock than we've anticipated, or get any information about these parameters that are sent with this custom report, we currently can't get any of that information with this report. And basically, here's the deal. The way Firebase Analytics works is that every day the service gets millions upon millions of events for all of your apps. And every few hours, they process this raw data into these generated reports for you to view at your leisure. And while these reports are kept around for you to view whenever you want, this raw data is not. which means that if you want to run complex ad hoc queries or on historical data, or export your data to use with other analytics packages, or simply run custom reports that you don't get out of the box with Firebase Analytics, you're going to need access to that raw data. And that's where BigQuery comes in. I'm guessing here at a Google Cloud event, I don't need to give you a whole lot of detail on what BigQuery is, but for those of you watching at home, it's Google's data warehouse in the cloud that's designed to run very fast queries over very large amounts of data. Data like the kind of analytics event data an app with a whole bunch of users might generate. And so the idea is that when you link your Firebase account with BigQuery, which you can do through this handy little panel in the Firebase console, it's under settings, it's a little gear icon, you can look for it. Then when all this analytics data from your clients gets sent to Firebase Analytics, a copy of that data also gets sent to BigQuery, and this happens in near real time. BigQuery stores this data in sort of a temporary intraday table, and then at the end of the day, copies it over to a more permanent table that you can keep for as long as you'd like. And so you can query these intraday tables if you want something resembling real-time analytics, or you can sort of look at these historical tables if you want to look at historical data over time. Now, I should note that if you want to use BigQuery, it's not entirely free. You will need to upgrade your Firebase project to the Blaze pay-as-you-go plan. And on the BigQuery side of things, you will need to pay for the data you store, the cost of the real-time streaming inserts, and the usage. However, if we were to take a look at a sample game like Bingo Blast, which right now has about 20,000 monthly active users across iOS and Android, records 70 different event types and 10 different user properties, right now our data storage charges come up to about 60 cents a month to store the previous 10 months worth of data. We're also paying about 12 cents a month to insert that data into BigQuery in real time. And then if we were to run a simple query across, say, a month's worth of Android data, that costs about 1/10 of a penny. If we were to run 50 queries like that every day across both Android and iOS, we'd be looking at about $3 a month. However, it turns out that BigQuery offers you 1 terabyte of usage data for free every month, and this falls well under that free tier. So this part actually costs nothing for a grand total of 72 cents. Now, obviously, huge disclaimer here. These figures can vary considerably depending on how much data you're collecting, how long you keep it around for, and how often and how complex you're making these queries. But at least for our sample app, linking to BigQuery did not involve a huge financial hit. And I should also note that there are sort of some tools in place to set quotas or alert you if pricing goes over what you're expecting. So looking back at our sample app, there are a few questions that I want to be able to answer that I can't right now from Firebase Analytics. First, give me some more information about what achievements were actually unlocked by this unlock achievement event. Second, while it's nice that I can filter my events by a single user property, I'm actually interested in filtering by 2 user properties, right? Like, for example, what if I want to see our spend virtual currency event for our users who speak English and also have power-ups, right? Filtering by 2 user properties at once is not something I can do right now with the out-of-the-box reports. Third, I want to generate a few custom reports that span both my Android and my iOS data. And in theory, maybe I want to combine this data with data coming in from another analytics tool that my app is using. And then fourth, I want to see what's causing my users to spend virtual currency in my game. Sure, I can see reports on this spend virtual currency event itself, but what are the events that lead up to that event? That's something that would be pretty valuable data to me as someone who wants my users to spend money. So these are all areas where analyzing the data in BigQuery might help. And now before we do that, before we get into the demos, I do want to explain what our data is going to look like. Because I don't know about you, but I sometimes think of BigQuery as like a giant SQL table, right? And if you've played with any of our public sample data, like the New York City taxi rides or Hacker News posts, this is kind of what it looks like. And maybe you knew this, but I didn't. BigQuery is really much more sophisticated than this. Like, the rows in BigQuery aren't really single rows that consist of one line of data. They're more like individual JSON trees that are all crammed into each row, right? Like, each of which can contain key value pairs and arrays and objects and arrays of objects. And that's important to understand when you're looking at Firebase Analytics in BigQuery, because one of the first things you might assume is that each row in BigQuery corresponds to a single Firebase Analytics event. And that's actually not the case. More often, a row in BigQuery will consist of a set of user information, and then probably like 2 or 3 events bundled together for that user. So let me explain by showing you what our actual data scheme looks like. So our user info section here, it contains a few straightforward key value pairs like first open time and some kind of unique ID that you as an app developer might provide. But then they also contain a number of nested objects that all have their own set of key value pairs. Things like the device that the user is using, their geographic location, the traffic source information, what marketing campaign brought them into your app, and so on. We also store user properties that we've associated with this user in the Firebase Analytics library. And these properties are basically stored as an array of objects. These objects, in turn, contain the name of the key as well as the value. And the value itself is an object that has an int value, string value, double value, and so on. And you'll find that in practice, most of these are null, except for the property that contains the actual value you're interested in. This basically allows you to store sort of any number of user properties in any format, and they're kept inside your BigQuery table in a consistent manner. And the nice thing about sort of keeping your user properties in a big nested array like this is that there's basically one less join that you need to worry about later when you're building up your queries. And you'll start to see that in the demo in a little bit. So then in addition to all this user information, there's some event information. And as I mentioned earlier, BigQuery tends to store these Firebase Analytics events as like an array of 3 or 4 event objects all bundled together in the same row. These also contain some straightforward key value pairs like the name of the event and the timestamp when this event occurred within your app. But then they also contain an array of event parameters. And just like user properties, these parameters have keys and values, and these values themselves are their own little objects that contain string value, int value, double value, and so on. And that's pretty much the data structure that you're going to be dealing with in Firebase Analytics in BigQuery. So with that in mind, let's revisit my initial list of questions that I couldn't get answered by Firebase Analytics alone. And we'll start with that first question. What achievements are actually getting unlocked with this event? This is something our game design team really wants to know. So luckily, querying custom parameters like this within BigQuery is something that really any halfway decent SQL developer could put together. Turns out, though, I am not that developer. Honestly, I barely know what I'm doing up here. Luckily, I'm here with Arun, who does. So he's going to walk us through some live examples on how to perform some of these queries using some actual Firebase Analytics data in BigQuery. So Arun, why don't you take it away?
Thanks, Todd. Hi, everybody. So in order to answer Todd's questions of which achievements are getting unlocked in the app, let's actually see some Android code that you need to implement. The Android snippet here shows the unlock achievement event being added to Firebase, with the name of the achievement, coins100, being added as an event parameter, a custom string parameter. Similarly, when the user clicks other achievements in your app, such as user power-ups, daubs, and coins, you can add those as achievement names as well. A few slides earlier, Todd showed us the schema of a Firebase record in BigQuery. The Firebase event and the parameter names that we just logged into in the Android snippet are shown in a BigQuery record as seen here. The unlock achievement event name is stored as a value in the first event's name field, and the corresponding parameter is stored as a value in the nested parameter string value field. Let's now do a quick demo. Demo, please. So this is BigQuery SQL editor, and we're going to use standard SQL for all our examples today. The query results show us the count of each unlocked achievement, indicating the most popular achievements in the app. This is just the results that we just ran like a minute ago. As seen here, the top achievements in the app are coins 500 and daub, both of which are equally popular. Let's now look at the actual query itself. Note the unnest syntax here. In the from class, the unnest iterates through an array of Firebase objects, which are event objects in this case, stored in the event dim record, and produces one row for each event. That's just a convenience function for you. Let's move on to another example. Earlier in the presentation, Todd showed you the events report in Firebase Analytics console. Here is how we can generate the same record in BigQuery. Demo, please. Slides, please. As seen here, the results show the top events and their event counts. The spend virtual currency is actually our second most popular event in the app, which is great. Let's look at our other open questions. Todd asked about filtering events by multiple user properties. In our example, we will filter the spend virtual currency event by the device language and powers, which are both user properties. Demo, please. Slides, please. The result shows that users with device language set to English and had power-ups in the app spent 2,250 virtual dollars in the app for a total of 218 times, which is great. Here is the query that we just executed. The query is in two parts. In the first part of the query, we apply the max function to all of the rows so that user properties are applied uniformly to all bundles of events for the given user. And in the second part of the query, we take the results from the inner query and only select those events for which both our user property criteria are satisfied, the power-ups and the language. Let us now look at other open questions. Let's now see how to combine our iOS and Android data. Demo, please. This is a cross-device query, and we'll shortly see it. Slides, please. The results show that while iOS tablet users are greater than iOS mobile device users, the results are just the opposite for Android users, which is interesting. Here is the query that we just ran. It shows how data from two different data sources can be combined in BigQuery. In this example, notice how we not only joined data across our iOS and Android apps, but in addition, we also joined our iOS and Android app data across multiple dates. Now, it turns out that our sample data is from a purely mobile app. But in some cases, you might also have a web app, in which case you're probably tracking your analytics in a tool like Google Analytics. It turns out that with BigQuery, you can combine data from Firebase Analytics with other providers, such as the data that you get from Google Analytics. You can join your iOS, Android, and your web data in BigQuery to determine user behavior across all of your apps. Let's now look at probably the most important question in our minds, which is on how you might figure out what's causing users to spend money in your app. In order to answer this question, we will build a sequence of events per user that leads up to the actual user actually spending money in your app, what we might call a custom event funnel. Here is a query that generates a sequence of 3 events. You can modify this query to really include any number of events you want in the funnel. The partition by class breaks the input rows into separate partitions by app instance ID, which is a proxy for user ID in this case. And the lead navigation function returns the next event based on an ordering criteria, which in our case is the event timestamp, thus creating a series of events ordered by timestamp. The results for part 1 of our query shows the 3 events for a given user. The user IDs have been masked for privacy reasons. As noticed in the interim result, the second event in the first row appears as the first event in the next row, and so on. Let's now look at part 2 of the query. We'll apply results from part 1 to part 2 of the query. In the second part of our query, we simply define our end event as the spend virtual currency event, since we would like to determine what users did before they spent money in the app. This query calculates the number of users and the frequency with which this funnel has been navigated. Let's look at the results. And it shows you what makes users spend money in a app. And you can see all of the different paths that users took before they spent money in your app. For instance, a lot of users spent money after completing a round, which is great. On the other hand, it also shows you that you, the developer, could do more to entice your users to spend money after spinning a slot or after leveling up. All good so far, except that the product folks don't want to deal with SQL. So what's the solution? Google Data Studio. Google Data Studio turns your raw analytics Firebase data into informative reports that are easy to read, share, and fully customizable. You can now create no-cost and unlimited charts and other interactive visualizations. Demo, please. In order to help you get started, we provide 2 sample reports that are based on a comprehensive set of metrics and dimensions available throughout your BigQuery schema. You can use these samples as templates to quickly create your own reports and visualizations based on your own app's raw data. And let's see how to do it. We'll now use the events sample report in a demo. So let's first take a look at some of the charts. So there's some basic dashboards, and then reports based on events, and also conversions. This is all in the sample report. Let's use this template, create a new data source, specify our BigQuery project, select the Android data set, and select events. Once we connect this data, we'll add it to the report. There you go. So this was your sample data here, and this was your own data, but generated with the same reports. You did not have to type or enter anything. You just had to go through a few clicks. It's that intuitive and that simple. Slides, please. Google Data Studio also lets you create reports based on custom SQL queries, and we'll see how to do it. We'll create a report using the events report query that we saw earlier in the presentation. Demo, please. So I'm going to copy the SQL query that we wrote for the events report. And in the Google Data Studio homepage, select data sources on the left. Select to create a new data source. Specify custom query, and select your data set. I'm pasting the query here that I just ran in the BigQuery SQL editor. And it's a standard SQL, so take off legacy SQL. And I create a report. Once I've added this data to the report, I can now create nice charts. So I'm going to do a pie chart for the events. Let's see how that works. There you go. So with just a few clicks, you have a nice pie chart, which will show you a nice visual illustration of all your events and their event count, thus making your product and marketing folks happy. Slides, please. To recap, Firebase Analytics is at the heart of Firebase and is a no-cost and powerful tool to meet all of your mobile analytics needs. Combined with BigQuery and Data Studio, you have a powerful analytics platform and querying engine in your hands. Thank you.